carried out about 7 operations on X. What you see on the screen, therefore, is the full notation of X. That is, whenever somebody writes this symbol X, it is a summary of many things that have taken place with X. It could be Y, it could be Z, it could be C, it could be other variables. But X is just used to represent other variables. Again, don't forget that we carried out 7 different operations on X, and they all turned out to be X. We used 5, and then afterwards you had to represent the 5 with X. We remember that we raised X to the power 1, and it still gave us X. We remember that we multiplied X by 1, it still gave us X. We also said that having X, that is plus X, is also X, or was also X. We also said that dividing the X by 1, or anything at all by 1, will give us that same thing. So in this case, when 1 divides all of these, the answer will still be equal to X. Then, square root of, cube root of, fourth root of the X, as the case may be, all to the power of the same degree will give us the same X. Don't forget. Then here, we have on the right hand side this sign. This is when we added 0 to X, it still gave us X. This one below is when 0 was subtracted from X, the answer was still equal to X. Therefore, 7 different operations have been carried out on X, and the answer is still equal to X. So whenever X is written like this, what is found on the right hand side is the full notation of it, which means it is when all of these are summarized that we get this X. Don't forget, students, that we carried out 7 different operations on X, and they all gave us X. So this is a summary of those operations. Let us now look at the name given to each of those numbers and the expressions indicating operations that were carried out on X to give the same X. These names will help us in the course of time to solve equations. Please don't forget any of these details that we are paying attention to. Right, the first one is sign of direction. This plus here is the sign of direction, showing that it is either having or owing. Right, so the plus here means that it is having. So if it is minus, it means that minus has to appear here. But because nothing is here, it means that what is here is plus. So that is called sign of direction. Then what about this 1 here? The 1 here is referring to the coefficient of X. So at all times, X or the any other unknown should have 1 as its coefficient. Then we have this 1 as power of X. Then this n on top is root degree power. It means the power of the entire expression, which corresponds to the root of the unknown X. So the next is the adder. The adder, this is 0 added to the X, or all other things that have been done to X before this adder came to be. The last one is this divisor. That which divides is 1. Therefore, we make conclusions respecting these names. If you watch, you will discover that we have roughly 6 different names given to different expressions and numbers placed around and on X to show operations carried out on 8 earlier, yielding X as the same answer. Why exactly are we talking about these names of numbers, names of expressions written on and around X in this notation? What is the connection between the notation and solving ordinary algebraic equations? Don't forget that we are just starting to learn the things that we should know to be able to solve ordinary algebraic equations. So what is the connection between what we see on the screen and all we have said so far and solving ordinary algebraic equations? The connection is in how the final solution to an equation should be expressed. For example, after solving a particular equation involving x, the answer could be expressed as just x is equal to 7. See it on the screen again. After solving a particular equation, the final solution to that equation could be expressed as x is equal to 7. What it means is that there was an equation and that equation included x. In fact, there was x as an unknown in that equation, and then that equation was solved. And after it was solved, the value of x, which was not known before, has now become known as 7. Therefore, a particular expression whose value was formerly unknown, that is x, has now become known as 7. In this case, the unknown has become the known. It is the process of finding the value of the unknown using equations that we refer to as solving equations. So to solve an equation means to find the value of the unknown, which when it replaces that unknown in an equation, will yield the answer as given in the equation. Finally, x was unknown and now it is equal to 7. It does not mean that each time we solve an equation that the answer is equal to 7. This is just a case in point. Every equation, after being solved correctly, will produce its own answer. This is just a case in point that is going to help us to know more about solving ordinary algebraic equations. After we solve an algebraic equation, we are expected to express the answer to that equation, a solution to that equation. Can there be an error in such expression? Yes, sometimes error occurs in expressing an answer to an algebraic equation. Together, let us learn how to avoid errors in expressing answers to algebraic equations. That takes us to lesson objective number 2. Please cooperate with me as I develop it. And now let's move to a second objective of this lesson, and that is pertinent characteristics of correct expression of solution to an equation. It is like an extension of what we saw in the first objective. Towards the last part of it, we saw this expression, x is equal to 7. Recall that I said that this could be one way to express an answer to an equation that was solved, so that at the end, the value of the unknown, which was x, has become 7. All right, let us focus on that expression, x is equal to 7. To learn by deduction some of the characteristics of this expression, we agree that this is a very fine way to express the final solution to an equation where the value of the formerly unknown x has become 7. We're going to deduce so many things from the way this expression of the final solution is written. Let's look at the first thing we can deduce from that expression. That's number A, 1. That is, the variable has coefficients of 1. If you watch this x here, you will discover that it has 1 as its coefficient, but not written. Scientists believe in saving time, energy, and space. By removing 1 from before that x, we are trying to save space. But you need to be informed that because nothing is there, it doesn't mean that there is nothing there. In actual sense, 1 is supposed to be there. So whatever you see thing, 1 is supposed to be in that position. That is why at the end, we learn that this 1x is equal to x, which means that this, in terms of coefficient, could have been the what is placed here before this x, but that was not done. It was replaced. It was removed to save space. The second one is that of number b that says the variable has 1 as its power. If you watch this x to the power, if you watch this x is equal to 7, that is nothing above this x. But here we tell you that something is there but unshown. So this is the way this should be, but it is not written. Because of that, what you have here is a summary of this in terms of power. The third one, that's number C, is that the divisor is 1. The divisor is 1. Just watch it again, and you understand that this x divided by 1 is equal to x. That is, this x which we have here is a short way of writing x over 1. It means that this is a summary of this. This is a summary of this. This is a summary of this. Let's go on. And that's number 4. It says the variable has 0 as its adder. And adder here is that which is added. It is either what you owe or what you have. What it means is that this 0 has become the adder to the x. If we add 0 to this x here, it remains the same x. It therefore means that what we have here is an extension of this x, and this x is a summary of this one we have at this point. What it thinks is that when this expression is condensed, it gives us this x. Therefore, this is a summary of this. Therefore, we say that x plus or minus 0 is equal to x. The number 5 is that of, that's number E. The variable is positive or having. If we come to this still, there is no sign that shows whether this x is what is owed or what is had. Whether it is having or owing, we don't know. But we learned earlier that each time such a thing exists or appears, whenever there is no sign before a number, either a variable or a constant, the actual sign before that number or the constant or the variable, when there is no sign written before a number, either a variable or constant, the sign that should be before that number is plus. Therefore, this plus x is a summary. This x here is a summary of this plus x. What it thinks is that here, nothing is shown. Here, something is shown to tell us the actual meaning of this x here. Students, I hope you are following these deductions and conclusions we're making from this simple expression. It means that this expression is a final summary. These things we are seeing here are extended expressions, expanded expressions, but when condensed, this is what we see. It is not out of place that we want to learn these expanded expressions that leads to x is equal to 7. Also, from this x is equal to 7, we learn that the variable is alone on one side of the expression. The variable, which is the x, which means that if you watch this, x is equal to 7. Even if it is x is equal to 7 plus y, one thing is clear. Whenever solution to an equation is written, we should not conclude that we have given the correct answer or the correct expression to that solution, except we write that solution in such a way that the unknown, which now is known, appears alone on the either left-hand side or right-hand side of this expression. So here, this x is alone here. Even if there are more things than this 7 on this right-hand side, as long as this x is alone this side, it is a correct expression. But if we say something like x plus 1 is equal to 7, please, students, that is not a final and a correct expression of solution to an equation. Or if we say x minus 2 is equal to 7, no. Please, at all times, after we offer solutions to an equation, the formerly unknown, which is shown with a symbol, should be written to be alone on one side of that expression, as we have in this one, x is equal to 7. Finally, let's consider number G. That is the last deduction or conclusion we can make from the way this final solution is written, and that is that the variable appears only once in the entire expression. It appears only once in the entire expression. It will be wrong to write x is equal to 7 plus 2x. Students, x is equal to 7 plus 2x is a wrong expression of the final answer. That unknown should appear only once in the entire expression. Anytime you solve an equation and the unknown, which you have been looking for, or whose value you have been looking for, comes to appear more than once, just know it that that expression is a wrong expression of the answer. Therefore, at all times, let the variable which has been found to possess a value appear only once in the entire expression of the answer to the equation. Therefore, the expression x is equal to 7 is a simple way of writing it like this. This is supposed to be the complete expression of an answer to an equation. But look at how it has become. Simpler here, more complex here. What it thinks is that this is revealing the things we simplified to make it become this. Surely the power is equal to 1, the coefficient is 1, it is having or positive, the divisor is 1, and the other is 0. Because this 1 is here but not shown. This 1 is here but not shown. This plus is here but not shown. This over 1 is here but not shown. This plus or minus 0 is here after it but not shown. Therefore, x is equal to 7 is a simple way of writing this expression. So, what it means at this point is that solving an ordinary algebraic equation would therefore mean carrying out operation that would eventually make the variable in the equation possess all these characteristics. There are characteristics of a correct expression of solution to an equation. You saw many of them just a short while ago. What it means is that solving an equation means making the unknown in that equation possess those characteristics. That is, to solve an equation that has x as the only unknown means carrying out operations that will eventually make it have 1 as its power. If currently in that equation it doesn't have 1 as its power. It also means carrying out operations that will eventually make it have 1 as its coefficient. if it doesn't have 1 as its coefficient in the current equation. It also means making that unknown become positive, if not positive, in the existing equation. It also means that it also means making the unknown have 1 as its divisor, if 1 is not the divisor in the existing equation. It also means making the unknown have 0 as its adder, if 0 is not currently its adder. These things are what we are expected to know and practice as we solve ordinary algebraic equations. Now, let us look at some cases, some examples of equations, and then with those examples, we try to learn how to forge ahead from this point.